Hello, community. So great that you are back. Yes, we talk about an old friend today, about RAG. And maybe this is the state of mind I should be in. But I think, okay, let's start. I need a 1-minute summary if you're not familiar with RAG. Otherwise, just skip 1 minute. RAG. Seems an eternity ago we used RAG to integrate external data into the reasoning process. And then we discovered, hey, the external data representation does not have to be in a vector space. It can be in a knowledge graph. And we built LLMs with an understanding on how to navigate a knowledge graph. And here Harvard, you see here on the right side, presents a new knowledge graph agent for medical AI. So we moved here from a classical RAG system to agents on knowledge graph, and this was already amazing. And then you see here some of my videos where we went here from single agent to multi-agent to Monte Carlo tree search to graph multi-agent research, 7 agent on a knowledge graph. My goodness, we had so much fun here. And of course, we moved beyond the graph RAG, a light RAG, a path RAG. And I showed you sometimes, even in 48 hours, we have more than 50 new RAG ideas here in, I think it was April, May 2025. And all was to integrate reasoning, advanced reasoning in our RAG pipeline. But of course, we had the reasoning not just as a reasoning, but we also have some self-reflective AI, some rule-based architecture, some command structure, some advanced tool use, RAG MCP, function calling got easier and easier, and I even have a specific video on MCP RAG for self-evolving agents like Alita that we have a deep dive here, technical deep dive here in this video. But now let's come to the end of my 1 minute, and in my very last video I showed you Anthropic secret, how to build multi-AI agents, and I got some questions, and you said, so help me, what is this, a RAG system? An agentic RAG system? You talk about multi-agentic RAG system? Can I implement a knowledge graph for a knowledge graph RAG? And where's the reasoning happening in this RAG system? Now, we all know that it is not anymore the classical RAG system, but people love, the community loves the term RAG. So, whenever we integrate here external data into our artificial intelligence, it is still RAG. So, let's live with this. And I'm a little bit disappointed that none of you got it right, because of course it's a prompt-based multi-agent reasoning RAG system with MCP tool, and sometimes temporarily we have an agent-to-agent communication protocol. You see, as easy as that. So, let's start now, and now let's have a look what we are talking about. I think it's time for a new understanding, for a new explanation. So, we are talking today about a reasoning agentic RAG system. And more or less you can have two paradigms, a predefined reasoning and an agentic reasoning. And you immediately understand what it is, because in the predefined reasoning, as you can see here, we have a root-based, loop-based, tree-based, a hybrid. And here you have from self-RAG to C-RAG to Monte Carlo tree search RAG that I showed you in my videos. Here you have them all, and those are the papers here from 2024 and 2025. But then I think this is now interesting. Now we have an agentic reasoning. Finally, we use the intelligence of our agents. And here too we have an option, prompt-based, like the classical React or the self-ask, and the training-based. And now you know training-based, if we look at the deep research or at Manus deep research, the core, the training-based, this is more or less reinforcement learning. So, just to make sure, the new term is reasoning agentic RAG, and we define here a predefined reasoning, where we have a question, the LLM does here a decomposition, because the complexity of the query might be too high, or the user did not use here a very specific formulation, so the LLM optimizes this, maybe decide it's time to have multiple sub-questions, we retrieve this, we reflect it, and we answer it, great. The other one, the agentic reasoning, is much more interesting. No, absolutely. So we have a question. We already have sub-questions. We have a large reasoning model now that starts queries, searches for helpful information, retrieves documents, reasoning and distilled information, reason in the documents, takes all the documents, the context of the documents for the specific reasoning, for the specific query, goes into an iterative loop, comes back, says, yes, I think the reasoning here could be argued because of, and we have a final answer. And isn't this beautiful? And of course, we have here from the agentic reasoning here, two options. The prompt-based instruction, where we define in our long prompt exactly what we want. And then we have the training-based. And again, reinforcement learning. Now, if you want to see this in a time axis here you have the predefined reasoning. And here you have the agentic reasoning. In red, you have the prompt-based. And in green, you have the training-based reinforcement learning. And you have here R1 as one of the definite reasoning traces generating model. How beautiful. And we're about here, and let's have a look at the future. Now, my video yesterday was absolutely clear. No? It was a reasoning agentic RAG system with agentic reasoning that was prompt-based. Do you remember? And the training-based version would have been here this, what we had a look at in one of my earlier videos, or like Deep Researcher. Scaling deep research via reinforcement learning in real-world environments. And today we have a new paper. Yes, today we have this paper here, June 12, 2025. Reasoning RAG via System 1 or System 2. Remember this? Slow and fast thinking. And they give us here a survey on reasoning agentic retrieval-augmented generation for industry. And this is beautiful because we have here East meets West. We have here the Beijing University of Post and Telecommunications. We have University of Georgia, we have South China University of Technology, then Germany, Technische Universität München und die Universität in Köln, then we have SenseTime Research and the Shanghai Jiaotong University. Unbelievable, what a beautiful international research team. And they come together and they tell us here, look, I think we have to be aware that RAG is here. Just look at this paper here. June 13, RAG Plus here by Huawei Technology. So even RAG is not anymore the real specific technical terms, but the word RAG is so familiar. We continue to use it and we say Super RAG and RAG Plus and RAG Plus Plus, and we build all the different beautiful technical terms. Just understand, we're gonna stay with RAG. Beautiful. It's all about now the integration of intelligent reasoning. Artificial intelligent reasoning into the RAG pipeline. It has nothing to do with the classical RAG system anymore. But let's come back to the main paper of today. And this old System 1 thinking, this fast, automatic, intuitive, rule-based. This is the old system. We forget about it. So what is so beautiful about System 2 thinking is now that our large language model, the core of the agent, is now an active decision maker. It is really here a central player in the dynamic process here of RAG, because it decides when to search, what tools to use, how to decompose here a higher complexity problem, how to synthesize the finding. I've shown you here in my last video here, we had here an orchestrating agent. This is it. So we can say, looking back at yesterday, Anthropic system here is a textbook implementation of a System 2 agentic reasoning system in the latest technical term implementation. Beautiful. Now we know what we are talking about. But you remember, this agentic reasoning had two options, no? Prompt-based and training-based. Well, if you have seen my video and you have seen here the beautiful prompt here by Anthropic that they published, you know immediately it is prompt-based. Let's look at this a little bit more in detail. So a prompt-based agentic reasoning system with a multi-agent orchestration. We had a lead researchers who spawned multiple sub-agents, and each performed its own agentic RAG loop, either in parallel or in sequential, depending here on the dependencies. And of course, we used here MCP for the tool calling here and specify the tools. And I showed you here that there's a certain kind of an agent here, a tool optimization agent for interactive for the reasoning loop. Great. But you know what's really interesting? Really interesting is now this question. Why don't we have a super intelligence right now? If you think about OpenAI, Sam is telling us now, I think for 5 years, The next model will be a super intelligent model. And I look at this and I say, but why does Anthropic now, in this real world case of yesterday, need to create 15 agents? Why? Can we just operate with one AI? Why we need 15? Because this is super AI, let's call it not superhuman, just call it a super AI, whatever it is, never mind. It should solve a complex task. That's all I'm asking for. Because what we do today, and let's say here with yesterday's Anthropic AI, we reduce a high complexity task into up to 15 lower complexity, means simpler subtasks. Why? Because our stupid agent cannot solve a high complexity question. So we have to break it down into up to 15 lower complexity subtasks that the AI is at least able to find it. And the core of each agent, we have an LLM. And you can go with an identical LLM, or you can have specialized LLM if you work in finance or medicine or physics or mathematics or whatever. And you have highly specialized network of agents here interacting. But we have still to reduce the complexity because we still have no super AI. So we have multiple agents and we break it down, we further break it down in the complexity till the task becomes so simple, but we use up to, 15, 25, 35 agents. Is this really the way in the future? And you know what? We use human patterns. And I said, that's not possible. Again, wherever we go, if you read here or have a look here in detail here at the prompt here by Anthropic, we use the dynamic here of this multi-agent system that we know from the human offices. No? We have a boss, and then this boss here in the division has 4 or 5 workers, no? And each worker is kind of a specialist, and we have multiple divisions and multiple departments, and then we have multiple, sub-CEOs, and then we have a CEO and a CFO. And I said, my goodness, we group here AI according to the human understanding of dynamic teams. And also the complexity reduction is done here on the human pre-trained patterns. We showed each of those LLMs in their pre-training phase. So those LLMs have never seen anything else than human patterns, and they don't know how to do anything except the human patterns. So wherever you look, you have human patterns. And now Anthropic tells us here in the prompt-defined agentic reasoning of their system that the humans define here the rules. This means the prompt structure. And you have seen this in my video of yesterday. Pages of exactly defined rules by human how AI has to behave. So we have human patterns on each and every level of complexity and of interoperability of LLMs and of agent and of communication and of data transfer and of decision making. Only human patterns. And maybe you got a feeling now what I want to communicate to you. If we have human patterns from start to end, from the pre-training here to the decision making, human defined the rules of adaptive AI system, human generated pre-training dataset for specialized LLM training, the human complexity breakdown here for the complexity reduction. So why the hell do we not have yet a superhuman intelligence? Because we know AI is a perfect pattern machine. And if we feed our AI only human patterns, where's the superhuman intelligence? You know that I'm smiling here, but you know, there are reasons now that we get from the group, from the international corporation. No? Human-like solutions are the best. No? Because by structuring it like a human team, tells us, for example, here Anthropic or other corporations, they create a familiar debugging interface here for us. No? And because if the research output is kind of bad, an engineer can ask the question to pin it down. No? Was it the manager? This means the lead researcher. The planning itself that was flawed? Or were the instructions to the specialist to our sub-agent unclear? Or did the specialist itself, the sub-agent, fail to execute here a clear instruction because it had problems to understand here MCP protocols? Or maybe coming back, all the RAG data now coming back here into our agentic system was the synthesis phase done by the lead researcher, but the boss is writing the report himself. Is it where this error occurred? Where did it happen? So for us humans to find here familiar management systems in the AI corporation structure is now, hey, this is what we need to understand and optimize an AI system, because the cognitive structure that we as humans analyze AI system, if it's kind of similar to the internal AI system itself, we can reason about it, we can find the errors, and we can do the debugging much more easier. Yeah? And of course, if you read it, there is another reason, because we have to keep the super intelligence on a leash. Yeah? Oh yeah, when I read this. So the management hierarchy is a powerful control structure, I am instructed. Yeah? And the lead researcher prompt is nothing else than a beautifully crafted corporate policy manual designed here to constrain the behavior of the entire system so that it is safe. Nothing can happen to the human user. No? And all the sub-agents are only given a very narrow firewalled responsibility. And the idea is, if we do this, if we constrain the system to the max, then it is a well-behaving, controlled, safe system. Or maybe this is the wrong idea now. Because I did an experiment and I told my AI, after all these anthropic prompts here, I told my AI to be super intelligent. And it said, hey, that's a real, that's a simple idea, no? And I said, yeah. But I thought once this human-style AI team is fully mastered by my AI, no? It is now time to use the AI itself to design a better architecture for the superintelligence, because Sam told us, no, it's coming in the next weeks for the last 5 years. So I designed a prompt, no? And I told my AI, hey, you are a metacognitive system architect. Analyze the communication logs and the performance bottlenecks of the previous lead researcher hierarchical model from Anthropic. Design and implement a new superior collaborative protocol for our multi-agent system that minimizes the redundancies and maximizes the synergistic discovery, even if the structure seems non-intuitive to humans. And I just wanted to give my AI the possibility to break free here from Anthropic's prompt. No? So what do you think happened? Do this experiment with your AI. Mine came back and said, okay, I have to change the protocol. I call it now a synaptic mesh protocol. Dismantling here the rigid hierarchy. I replace here the discrete lead and the sub-agent with a fluid swarm of specialized cognitive processes that collaborate here on a dynamic information canvas. And then, of course, I build a swarm structure now, an agent swarm. I have no fixed roles, I have no fixed agents, just functions. No? I have here different kind of agents, each with a defined functions, and they work together given the complexity and they decide themselves. So we move here from a prompt instruction to an agentic reasoning, to really a thinking to model in the purest sense here. I found it interesting that my AI defined this. But of course, already 1 year ago, you remember we did a video here on the swarm intelligence of AI multi-agent ecosystem and how AI swarm intelligence can emerge. And this was done here a year ago. So I thought, okay, that's somewhere here in the parametric knowledge of my AI, no? And then it came back and said, hey, you know this shared mimetic canvas? I develop a new data structure. I replace here the Anthropic file system and the typical Anthropic message parsing here that we have. And I build a real-time multidimensional knowledge graph where all agents can read and write. The entry on the canvas is not just text, but we have multiple metadata, the payload, the RAA, this confidence score, contradiction flag, information entropy, this is really interesting, and a tool reliability score. So I said, interesting. And then they came up here with a classical gradient protocol. No? Communication protocol replaces here the static delegation protocol. An AI agent does not just report up to its boss, and I criticized this yesterday in my last video. So it's kind of broadcasting its finding to the entire mesh communication structure. And if a discovery is with a high information entropy label, so a surprising fact, this propagates now throughout the complete mesh instantly. So this was an interesting idea. And I said, hey, I give my LLM now the freedom, and I run here a benchmark test here on multi-agent performance. So in some hours, maybe if you're interested in one of the next video, I can give you the result. But hey, try it out yourself. An example. I said, hey, analyze the near-term viability of cobalt-free kind of batteries, considering your supply chain, geopolitical factors and so on. And the classical anthropic system, what it does. We went through this yesterday. Ne? Plans here, agent A for the supply chain, agent B for the geopolitics, and an agent C for the performance. So exactly here, given here the complexity of my query. Ne? All three agents are employed with a budget of, we have seen this yesterday, 15 tool calls, especially also defined here in the prompt structure itself. But then imagine A and B have a discovery, and they discover here something beautiful that they could have discovered as a single agent. So they're kind of wasted their budget here on redundant work. And then agent C discovers here a breakthrough somewhere else on an archive or wherever in a database here, but it has also exhausted here its hard limit budget. So before it can really have a deep dive in this new paper citation and understanding it, it has to return a report. It has to stop it because we have a hard limit budget here in the prompt of Anthropic. And agent B also finds some minor political issue here in a secondary source. So everything is coming back. Everything is on their max budget. Everything is reporting now back here to our lead researcher. And our lead researcher, one, synthesizes now a kind of an incomplete report from C especially, and some minor issues here from B, and delivers here some kind of optimistic, but kind of inaccurate assessment because simply they did not have enough time. Their hard-coded limitation did not allow here for a real deep dive. And the key insight from one of the papers that was found was completely lost. You don't want this to happen. So my system told me, so me tomorrow, a new idea. So just to map out this idea, do you have an agent that maps here 3 initial vectors onto this mimetic canvas? So 3 prosecutor agents are spawned, each with a different vector. And now imagine one agent finds now accidentally a real foundational article, a real interesting article. Now before 2 and 3, the agents start, and they start with their web search. And you remember yesterday we spoke about a topology of our multi-agent system of hub and spoke design. Now the agent can communicate. And this agent who found something really interesting, before the other 2, 3 agents start, tells this other agent, hey, I found something really interesting. Integrate this in your reasoning process. Because analyzed high information entropy score, communicate this across the mesh to all the other existing supply chain data on the actual canvas will now be updated with the new findings. But before this is happening, we have now a contradictor agent or a validation agent. And this job of this agent is now to ensure that this is a valid information, this is a robust information. It's now testing out here this evidence. And only if this agent gives its okay, that say, okay, this is not some BS or some political motivated information that is not based in facts, only with an okay from the contradictor agent, then it is integrated in the system, dynamically allocated, then more resources to this specific vector, and you can send out 2, 3 more agents that have now a real extensive technical deep dive into this paper. You can allocate quite a lot of resources to really try to understand here the technical concept of this particular paper. You get a complete different result back. So just to show you this very simple, very trivial example here from my AI, but try it out yourself. I think it's interesting, but I also had another idea because, as you can see, all of this that I just showed you is again a simple human pattern. There was nothing super AI in this. And I know you might think, yeah, but it is, the combinatorial evidence, and then we have more data and more data. But you know that more data is not more information, and more information does not mean more knowledge. So don't fall for the same traps. But at the end of the video, I would like to tell you something. I defined now my first theorem here on this channel, 001, and you know what this theorem is? AI can only be human. Prove me wrong. See you in my next video.